In 13.2, let's look at reflections and glide reflections. Another isometry is a reflection or flip. One example of a reflection often encountered in our daily lives is a mirror image. A reflection is a line L is a transformation of a plane that pairs each point P of the plane with a point P prime in such a way that L is the perpendicular bisector of the segment P prime. As long as P is not on L, if P is on L, then P equals P prime. Essentially what we're doing is we have the line L and a point P on one side of the line. We are going to reflect this image across the line L, and we want to make sure that image will be reflected in a perpendicular fashion. So we have the point P is reflected across to another point P prime, and the segment is bisected by the line L at a perpendicular angle. Example 1. I want to find the image of triangle ABC under a reflection in line M. So we have the line M, and I want to reflect this triangle on the other side. Since the point C is on the line, we know the reflection of that will be on the line itself. So C is going to be equal to C prime. Now the point A is going to be reflected across, and it will be reflected across at a perpendicular angle to the line M, and here's our new point A prime. B will also be reflected across the line M, and we want to make sure it's reflected at a 90-degree angle compared to the line M. And so B prime is at this point now. It is equidistant from the line M, and it is at a perpendicular angle with the line M. So here we have a new point here, B prime, and now we can draw our triangle. And here is our reflection across the line M. For some reflecting lines, like the x-axis and y-axis, and the line y equals x, it is quite easy to find the coordinates of the image given the coordinates of the point. For example, if I have the point 1, 4, I can reflect it across the y-axis at the point 4, 1. So essentially, I am swapping the x's and the y's to reflect it across the line y equals x. So here, the y is in place of the x, and the x is in place of the y. If I want to reflect the point -3, 0 across the line y equals x, then the b prime coordinate is 0, -3. Again, we just swap the x's and the y's, and it would reflect across the line y equals x. Another basic isometry, a glide reflection, is a transformation consisting of a translation followed by a reflection in a line parallel to the slide arrow. Essentially, we are going to transform the car in one direction, and then we're going to take the image of this car and reflect it about the line M. This is known as a glide reflection. We're both doing a translation and then following that up with a reflection. It is possible to define two figures as congruent if and only if one image is an image of the other under an isometry or a composition of isometries. We're going to show that triangle ADC is congruent to triangle CBA. So triangle ADC is this triangle here, and we want to confirm that it's congruent to this triangle CBA. And in order to do that, we're just going to consider a half turn. A half turn of triangle ADC with the center E will give us that congruence. Now, why does that work? Well, if we do a half turn this way, we're going to end up with these triangles on top of each other. And if I can show that angle D is congruent to angle B, then we have the angles are the same. And we know that this angle will be congruent to this angle. And so by angle, side, angle, we have a congruence. In part B, I want to show the triangle ADC is congruent to triangle BCD. BCD. The best way to do that is to do a reflection across a vertical line that runs through the point E, and I want that to be parallel with AD. If I can reflect this triangle across that point and get the same image exactly, then I know that these two triangles are congruent. A reflection in a line passing through E and parallel to the segment AD is one transformation we can use. For part C, I want to show that triangle ADC is congruent to triangle DAB. DAB. And for this one, we could do a reflection again. We could do a reflection again across the point E and parallel to the segment DC. A reflecting of triangle ADC in a line passing through E and parallel to DC is one transformation we can use.